In this video, we'll look at integrating an expression involving powers of sine and cosine. The example I've chosen is sine squared of 2x times cosine squared of 2x. The first observation to make is that both of the powers are even degree. I have sine squared and cosine squared. When you see exclusively even degrees, you should consider using the power reduction identities. I've written them over here on the right hand side for review. Sine squared gets replaced with 1 minus cosine of the double angle, 2 times x. A similar expression for cosine applies. Notice the only difference is the sign in the middle. Both of them replace it with cosine of 2 times x. In this case, I'm going to replace both instances of sine squared and cosine squared with their respective power reduced versions on the right hand side. However, notice the angle is 2 times x, so when I apply the identity, twice the angle will be 4 times x. Let's do it in the first instance. Sine squared will be replaced with 1 minus cosine of twice 2x, that will result in 4x, all over 2. I then do the same thing for cosine squared of 2x, the only difference being the plus in the middle. I now have an expression that looks complicated, but if I expand it out, will result in terms which are simpler to integrate. I'm going to multiply everything out in the numerator. I have 1 times 1. I'm going to then take 1 times cosine of 4x, and then minus cosine of 4x times 1, and both of those middle terms will cancel out. The only remaining term will be minus cosine of 4x times cosine of 4x. That will give me a minus cosine squared of 4x. In the denominator, I have 2 times 2, so it will be a fourth. I'll separate this into two terms, 1 over 4, and then minus 1/4 times cosine squared of 4x. When I see that cosine squared of 4x, though, I'm going to use this power reduction identity one more time to reduce the degree. Because the angle is already 4x, when I double it, it will become 8 times x. So I'm going to now replace it with 1 plus cosine of 8x over 2. Let's expand all these terms out and see what we've got. I've got 1/4 from the first term. I have minus 1/4 times the 1/2 that appears in the first term here, so minus 1/8. And then distributing the minus 1/4 through this to this term, I'll have minus 1/8 cosine of 8x. Let's simplify. I have 1/4 minus 1/8, that gives me positive 1/8. And then I have my minus 1/8 cosine, and I'll just rewrite that, and we'll need to integrate both of those two terms. The first term will be linear, 1/8 x. The second term will be sine of 8x, and I have to divide by 8 to account for the 8 that appears inside the argument. So I'll have 1/8 times 8, and simplifying, that will give me 1/64 times sine of 8x. Let's review how we did this calculation. I had a powers of sine and cosine. Both of them were even degree. I therefore replaced them with their power reduced versions, which doubles the angle to 4x. I expanded everything out. When I did so, I still had a power of cosine squared, and I reduced it one more time, continued expanding, and I had something that I was now able to integrate. Integrating term by term gave me the following expression.